So alkene means between the carbon and the carbon, there's a double bond, and if it is ene, the name should end at ene, and the general formula to get alkene, that is CnH2n. So means the number of the hydrogen are always twice as compared to number of carbon. For example, if I say write a formula for pentene. So pentene, pent means how many carbons are there in pent? N means the number of the carbon. How many carbons are there in pent? If prefix pent is there, that is 5. So it means there are 5 carbon. So the formula for pentene will be C5 and H2 and then N is 5. So it will be C5 and 2 multiplied by 5, that is equals to 10. So C5H10, that is pentene. If I say what is the formula for propene? Prop, how many carbon atoms are there for the prefix prop? So 3 carbon atoms. So N is 3. So it will be C3NH6. Same way, if I say heptene, hept means the value of N is equals to hept. Oct means 8, hept means 7. So N is equals to 7. If N is equals to 7, so 7 multiplied by 2 is 14. So C7 and H14. But when we take the empirical formula is the simplest ratio. So you can see when I find the empirical formula of each, C5H10, the simplest ratio is 1:2. C3H6, the simplest ratio is 1:2. C7H14, the simplest ratio is 1:2. So all these alkenes have the same empirical formulas. The empirical formula of all alkenes is same. But it is not necessary that the double bond is present with the first carbon. You may have a compound in which a double bond might be present with the second or the third carbon. So in that case, when you work out the name of the compound, you should number the carbon atoms, and the numbering should start from nearest double bond. So the numbering should start from the nearest double bond. Which position we, so if I count from the right hand side, it is 1, 2, 3, 4, 5. So between 3 and 4 is a double bond, but we take a smallest number, so 3. But if I count from left hand side, it is 1, 2, 3, 4, 5. Between second and third carbon, there is a double bond. So will means the second carbon is having a double bond. So we should follow numbering from left to right. So how many carbons are there? It contains 5 carbons. So 5 carbon, it is pent. And because the double bond with the second position, so it is 2, and ene because there is a double bond. So it is pent to ene. What is the name of this compound? What is the name of this compound? Contain 3 carbon and the double bond. It is propene or propanene. Because if I number from left hand side 1, 2, and 3, second carbon is having a double bond. If I number from right hand side, the first carbon is having a double bond, and we always follow the numbering from the closer. So it is prop because of 3 carbon, and 1 because of position, and ene because of double bond. Because the double bond with the first carbon, that's why it is not an issue that if you don't mention 1, you can even say it is propene. When you count from left hand side, when you count from left hand side 1, 2, 3, second carbon is having a double bond. When you count from right hand side 1, 2, 3, first carbon is having a double bond, because double bond is between 1 and 2, so that's 1. So you follow a numbering where it is closer, so this time it is from right to left, because right to left the first carbon have double bond, left to right the second carbon is having a double bond. So we always follow a numbering in which the double bond is closer. Then the reactions of alkenes. First thing, because we can use them as a fuel, so when we use hydrocarbon as a fuel, we can burn them. So as we can burn them, the first reaction is combustion or burning. So any alkene is there, generally a complete combustion will result. The combustion of any alkene will result in a formation of complete combustion, result in a formation of carbon dioxide plus water. Because these are hydrocarbons, that's why the product will be carbon dioxide and water for a complete combustion. So example, you have ethene, C2 and H4 reacted with oxygen. So the product will be carbon dioxide plus water. Balancing the equation, you start with carbon followed by hydrogen at the last oxygen. So first I'll start with carbon. I have 2 carbon on my left hand side, so I should put 2, so carbon is balanced. 4 hydrogen, so I should put 2, so hydrogen is balanced. What about oxygen? 2 multiplied by 2, 4, plus 2, 6. So I need 6, so I will put 3, so oxygen is balanced. So start with carbon followed by hydrogen and at the last oxygen. Is it clear, this balancing? Same way, if we have another alkene, like example C3H6, which is propene, and you be burned, complete combustion of propene result in a formation of carbon dioxide and water. So I will start balancing with carbon. I have 3 carbon. So to balance the carbon, I will put 3. I have 6 hydrogen. So I put to balance hydrogen, I put 3 as well. What about oxygen? 3 multiplied by 2. That is 6 plus 3, 9. So what number I should place here to get 9 oxygen? What should be the number at before O2 to make it 9? That's 4.5. So a 4.5 oxygen, 4.5 into 2 will make 9. But whenever you are using a decimal to balance the equation, you'll multiply all of them by 2. So when we multiply all of them by 2, so the final equation, it will be 2 C3H6 plus 9O2 gives 6CO2 plus 6H2O. And this is only in the case when you are using a decimal to balance the equation. If you are not using a decimal, then you don't have to multiply the whole equation by 2. The second type of reactions are addition reactions. The term addition reaction means when more reactants and only one product, like more than one reactant. So when more than one reactant and only one product is formed, these type of reactions are known as addition reaction. So what happens when alkenes react in addition reaction? So what happens in addition reaction of alkenes? The double bond of alkene break down into single bond, and the two atoms added to carbon containing or having double bond. I'll explain this statement. This is generally what happens in addition of alkene. The double bond will break it into single bond and the two atoms added to the carbon which were having double bond. Example, if there's a carbon-carbon double bond, this is a compound. How many hydrogen the first one will have? How many hydrogen atoms the first one will have? On the left hand side. 2 are already formed, so how many are left? 2. So 2. How many hydrogen? The second carbon from the left hand side? 1. How many hydrogen? The third carbon from the left hand side? 2. And how many hydrogen? The last carbon or the right hand side carbon? The last carbon will have 3. What is the name of this compound? 4 carbon with a double bond with the first. So it is butene. But because of 4 carbon and ene because there's a double bond. So it is butene. Now what happened in addition reaction? This is just general mechanism I'm explaining. And specifically you will learn different reactions. But this is general mechanism. So example, if there were reactant A and B. So A and B are reacting with this alkene. So what happened in this reaction? How the alkenes react? So A is added to the first carbon, and it can be other way around. A can be added to the second carbon, B can be added. So it can happen other way around as well. So example, B is added to one carbon and A is added to another carbon. And the double bond will break. So as this double bond will break, like originally there was a double bond. Now what happened? The double bond will break. So as this double bond will break, now these two carbons which are having a single bond now, they can form a bond, new bond. So which substance they will form a bond? The reactant, they will form a bond with a reactant. So one of them will form a bond with A and another one will form a bond with B. So the double bond will break and the reactant atoms added to each carbon atom. Example, reaction with hydrogen. And this is also known as hydrogenation. Hydrogenation means addition of hydrogen. So reaction with hydrogen, or we also call this as hydrogenation. So if we have alkene, so this was an alkene, which is propene. And it is reacting with hydrogen. Hydrogen means H2. So for hydrogen H2, what I can write? I can write hydrogen with another hydrogen. H2 means so H2 means hydrogen single bonded with hydrogen. Now first what happened when alkene react? So when alkene react, the double bond will break. So first we'll break a double bond. Here the double bond is there. So that double bond will break. So draw the same structure, but without a double bond. Now what happened? Because the double bond break, so these two hydrogen atoms, these are the two hydrogen atom, one hydrogen atom attached to the first carbon and the second hydrogen atom attached to the second carbon. So we have two reactants and we have only one product. When more reactant form only one product, we call this reaction as hydrogenation. So when alkenes react, their double bond will turn into single bond and the two atoms which are present reacting with alkene are added to the structure. So here if we are reacting with hydrogen, hydrogen means H2 or two hydrogen atom. So each hydrogen atom is attached to a carbon which was having a double bond. Is it clear? The hydrogenation, the term hydrogenation means addition of hydrogen. Any doubt in this part? So basically, as you can see, it was butene and this is a single bond, so it will turn into butane. So in a journal equation, when we say whenever any alkene is there reacted with hydrogen, it will turn into alkane. And you have to learn the reaction condition for this reaction. We use nickel as a catalyst and temperature around 200 degrees centigrade. You have to learn these reaction conditions. So when I will give more examples, when alkene react with hydrogen, this will result in a formation of alkane, like a compound will have a single bond. Another example, Reaction with hydrogen. This we are discussing the reaction with hydrogen. If we have, say, C double bonded with C, so this is okay, the previous was butene. Just a minute, I will change this into propene. So this is propene plus hydrogen. So when they react with each other, first thing what happen when alkene react, their double bond will break. So first thing, you will draw the same structure, but without a double bond. So draw the same structure without a double bond. Now what happened? The two hydrogen atoms added to the carbon which break the double bond. So because each carbon can form maximum 4. When there was a double bond, all were having 4. But moment the double bond break, now they can form one extra bond because 3 bonds are there. So one hydrogen attached to first carbon and the second hydrogen attached to second carbon. And what it will become? It will become prop N. Is it clear, this example? So alkene plus hydrogen will give alkane. Sometime you have to complete a word equation, sometime you have to complete a symbolic equation, or sometime you have to complete the structure. So if there was a word equations are easy to complete. The journal word equation for reaction with hydrogen, we are discussing the reaction of alkenes with hydrogen. So if I say ethene plus hydrogen, what will be the product? Ethene plus hydrogen. So it will be ethane. If I say pentene plus hydrogen, what will be the word equation? Pentene plus hydrogen. It will be pentane. Sometime you have to complete a symbolic equation, like if we say C3H6, which is propene, plus hydrogen. So what will be the product? So it is very easy to complete a product. Just add hydrogen to this structure. So it will become C3 and H8. If it is C9 and H18 plus hydrogen, what will be the product if C9H18 plus hydrogen? So C9NH20 will be the product. So this is a reaction of alkene with hydrogen, which we call hydrogenation. You have to learn the condition for hydrogenation. What are the conditions? Condition is we need nickel as a catalyst and we need around 200 degrees centigrade for them to react. And generally this addition of hydrogen is known as hydrogenation. The second reaction of alkene, and already we discussed, sometime they can ask to complete a structure of the product. So if reactant is given, so we just break the double bond and add the two hydrogen. The second reaction is reaction with steam. Reaction with steam, or you can basically, because the temperature is high, that is why it is steam, or you can also say reaction with water. When water is added to a compound, look, if water is removed from the compound, we call dehydration. But if water is added to a compound, we call that as hydration. Hydration means addition of water. So what happened, like example, if you have a compound, say propene. So this is propene. And we react with steam or water, and basically H2O can be written in terms of bond. If we are writing water, we can write it is H and OH. This H and OH basically combine to form this water. Now to complete a product, what will happen? We'll draw the same structure. We will draw the same structure. Without a double bond, the double bond will break. And now what we will do, one side we will add H and another side we will add OH. So it's up to you. You can add, like I can add OH with the second carbon and H with the first carbon. Or I can add OH with the first carbon and H with the second carbon. Both possibilities are there. So it's up to you. Now, if OH is attached to a compound, what we call that type of compound? If it contains OH. If a compound contains OH, so we call them as alcohol. So basically what happened, if we write a journal equation, yeah, OL is there, that's right, and the type of the compound is called alcohol. So if we write a journal equation, if you have alkene plus steam, this will result in a formation of alcohol. So this is one of the way alcohol. So alkene plus steam result in a formation of alcohol. And this alcohol, for formation of this alcohol, what are the conditions? Number one, we use phosphoric acid as a catalyst, and we use high temperature. Why we use high temperature? Because we need a steam. So you cannot have steam at room temperature. The temperature should be higher. Again, you have to learn the reaction conditions for this. So alkene plus steam result in a formation of alcohol. So if we write a journal equation, or journal reaction, the product. So if I have propene plus steam, what will be the product? Propene plus steam. Propanol. The double bond will break, so it will become not propenol, it will become propanol. Why propanol, not enol? Because the double bond break and OH is added. If it is butene plus steam, what will be the product? So it will be butanol. If it is pentene plus steam, what will be the product? So it will be pentanol. So alkene plus steam result in a formation of alcohol. So if you have to complete a symbolic equation, like if I say C3 and H6 and steam instead is better, instead of writing steam H2O, you can write H2O, that is right, but write HNOH. Why? It will make your product, like it will make it easy to complete a product. So if I add HNOH, so C3, 6 hydrogen are already there. If this H is added first, so it will become C3H7 and then OH will be there. Same way, if you write C4H8 plus H2O, what will be the product? C4H8 plus H2O or HNOH. So it will be C4. Look, 4 carbon are already there. Then 8 plus 1, like this hydrogen added, 8 plus 1, make it 9. And then OH right as it is. So it will become C4H9OH. If it is C7 and H14 plus HNOH, what will be the product? So C7H15OH. So that will be haptanol. So their reactions are addition reaction. All reactions are same way. Reaction with hydrogen chloride or HCl. So if alkene is there plus HCl, this will give chloro alkane. C double bonded with C, H, H, and it is reacting with HCl. So to complete a product, what we will do, we'll first break a double bond. So when we break a double bond, now we have two possibilities. Chlorine can be attached to first carbon, hydrogen second, or chlorine with the second, hydrogen with the first. So example, I attach chlorine with the second because the two atoms here, chlorine is there and hydrogen. So example, I attach chlorine with the second and hydrogen with the first. So what is the name of this compound? This was propene. What is the name of this compound? That's right, chloropropane. But because chlorine is with the second carbon, so if chlorine with the second carbon, I can mention the position of the chlorine. So I can mention it is 2-chloropropane. The term 2 means like chlorine is not attached with the first carbon. Chlorine is attached with the second carbon. Is it clear? But if I attach the chlorine with the first carbon, like I attach hydrogen with the second and I attach chlorine with the first, then it will not be 2 in that case, because the first carbon is this, then it will be 1-chloropropane, or chloropropane or 1-chloropropane is same thing. But 2-chloropropane and chloropropane are different. In that case, you cannot say both are same, because 2 is showing the position of the chlorine. Is it clear? The reaction of alkene with hydrogen so result in a formation of chloroalkane. This reaction can occur at room temperature. So there is no specific. So for this reaction, you don't need a catalyst, or you do not need a high temperature. Still, there are more reactions of alkenes, but we will not be able to complete within this session. So tomorrow, inshallah, I will complete the reactions of alkene, and we'll start alcohols, and we'll do some questions from alkane and alkene after completing it. Any question or a doubt related to the class? So we did the reactions of alkene, but it's not complete yet. Still, there are more reactions that we will discuss in the next session. So I'll end this session and share the recording with you.